All right, Algebra 2 students, today we are going to see some connections to things you've learned before. Let's start with the general quadratic function. And let's call it a times x plus b over x squared plus b over a times x plus c. Now I'm going to take half of this number, which is b over 2a, square it and add it here. So I'm going to add, I'll do this in a different color. I'm going to add b squared over 4a squared. But then on this side, I'm going to subtract b squared over 4a. So I didn't really add b squared over 4a squared. I added b squared over 4a squared times a. So on the same side of the equation, I'm going to subtract that. Now I have this equals a times x plus b over 2a quantity squared plus, and if you get like terms here, you get like 4ac minus b squared all over 4a. It's kind of a mess. I don't really worry about this value. I'm not going to memorize that. I'll just call that k. But look what we have here. We have a times x plus b over 2a quantity squared. And this looks a lot like vertex form because it is vertex form. And so one of the things that we will know about a general quadratic function is that the axis of symmetry is the line x equals negative b over 2a. Notice that this is a plus, so to fit that form, x minus h, you have to say that h is the negative b over 2a. And then that also means that the x-coordinate of the vertex is negative b over 2a. And the y-coordinate, well, you just find that by plugging negative b over 2a into the general quadratic function over here. And then you know that the y-intercept, which is another interesting point for quadratics, is c, because if you just plug in 0 for x, you get c. This should look familiar. This looks like part of the quadratic formula, and it is part of the quadratic formula. It's that first part, negative b over 2a plus or minus the square root of some mess, right? Well, if we write that quadratic formula out, x equals negative b over 2a plus or minus some junk, right? b squared minus 4ac all divided by 2a. You can start to see this in the graph of a quadratic. So if I graph a quadratic here, and I have this line that goes down the middle, that is x equals negative b over 2a. And then what I have is right here at this point called the vertex, I have that place where the discriminant is 0, right? And if I think about this vertical line here, if I set it equal to the quadratic represented by this red parabola, I would get one solution because the discriminant would be 0. And if I set that red quadratic equal to this horizontal line down here, I would get a negative discriminant, meaning there's no real solutions, only imaginary solutions. And if I set it equal to this this horizontal line up here, I would get these two solutions that just happen to be equally spaced from this line. And because we do negative numbers to the left and positive numbers to the right, this is what you get when you add the square root of b squared minus 4ac all divided by 2a to that equation. And this is what you get when you subtract b squared minus 4ac all over 2a. And so ideally, you're going to start to make these connections with things you've learned before with the things we're learning now. So the next unit is, how do you graph f of x equals ax squared plus bx plus c? And the way I would graph that is, the first thing I would know is the axis of symmetry is x equals negative b over 2a. I would then plug that in to find the vertex, because the vertex is going to be negative b over 2a, comma, f of negative b over 2a. And then, if it's helpful, I would find the y-intercept, which is c, and I would use symmetry to find a mirror point across the axis of symmetry if it applies. And then I can graph a quadratic if it looks like this, and don't have to put it in vertex form. You can always rewrite a quadratic in vertex form. So all quadratics have both forms. You just need to be able to write it using the completing the square trick that I showed at the beginning of the video. So how would you graph something like this? How would you graph f of x equals 2x squared minus 6x plus 5? Well, I would start and I would say, okay, let's find my axis of symmetry. It's negative b, I'm going to call this 3 to make it nicer, times 2a. So it's 6 over 6, which is 1. So I know my axis of symmetry is right here, the line x equals 1. So this is my symmetry. The next thing I know is if I plug in 1, I can find the y coordinate. So that's 3 times 1 squared minus 6 times 1 plus 5. And that gives me the vertex is positive 2, 1 comma 2. So now I would go to that point and I draw my dot for the vertex. And now there's a couple ways to do this. I know the y-intercept is 5, so I could go up here to 5 and mirror that image over. The other thing is that the a value doesn't change. That I could rewrite f of x as 3 times x minus 1 quantity squared plus 2 because I know hk now. And that means if I was to graph using what we did today in class, over 1 up, 1, 2, 3, over 2 up, 12, right? So 3, 6, 9, and then 12 would be way up there, right? Hardly even in the screen, not even really in the screen. So what you start to see is that vertical stretch that you get from that value of 3x squared, right? Now I made it a 3 because I wanted this math to be nice. I didn't want to deal with 6 over 4 because I originally had a 2 there. Good. Let's try another example. So what if I gave you the problem, what if I gave you the problem f of x equals 1/2 x squared minus 5x plus 3. Why don't you do what I did in the last example on your own, see how this goes, and then unpause the video. All right, so I always start with the axis of symmetry. The axis of symmetry is x equals negative b over 2a. So in this case, that's positive 5 over 2 times a half. That's positive 5 over 1, or 5. Now I'm going to plug that in to f of x. I'm going to find f of 5, and that's going to be 1/2 times 25 minus 25 plus 3. Half of 25 is 25 halves, minus 25 plus 3. So 25 halves minus 25 is negative 25 halves. Negative 25 halves plus 3 is like adding 6 over 2, right? And then that gives us a negative 19 over 2, which is what? Almost 10, 9.5, negative 9.5. So I go over to 5, and I go down to 9.5. Not the nicest value, but that's okay. Good. Now from that vertex, 5 comma negative 19 halves, I could go over 1 and up 1/2. Back 1 and up 1/2. I could go over 2, 1, 2, and up 2, because 4 times 1/2 is 2. So 1, 2, that would put me right there. And those aren't great points. These are nice points. Vertex not so nice. The other thing I can use is the y-intercept. The y-intercept is 3, so that means I know it's going to hit the y-axis here, so I can also just go over to this point and mirror that entire quadratic. And now if I was to graph this, I'm going to get a pretty nice shape. Now remember, my tablet skills are developing, but that's pretty darn good, right? Again, if I superimpose the regular x squared graph from this point, over 1, up 1, over 1, up 1, over 2, up 4, 1, 2, 3, 4, back 2, up 4, you can start to see how the graph in the red is vertically shrunk compared to the yellow graph. And then if I graph in blue 3 times x squared with the same vertex, that'd be over 1, up 1, 2, 3, over 1, up 1, 2, 3, over 2, up 12. So up 12, that would be 10, 11, 12, right? And then using some symmetry. And you can see how stretched that graph looks, right? Good. So again, quick recap on the next screen. I've said this a couple times, just want to make sure everybody has it. If a function is equal to ax squared plus bx plus c, you have two options. You can complete the square here, and be careful when you do that because it's all on the same side, and you can rewrite it in vertex form, a times x minus h quantity squared plus k, and do what we were doing today. And all quadratics have a general form and a vertex form. Or you can, and I think you should know this, the axis of symmetry is x equals negative b over 2a. That means the vertex is at the coordinates negative b over 2a and then whatever f of that value is. Just plug in whatever that value is into the function, find the y value. And then the y-intercept is at c. A still tells you the same things, if it opens up or down or if it's a stretch or a shrink. And what I love is this a value here is the same a value there. All right, guys, have a great night. Thanks for watching. Peace.